Let us discuss a question from thermodynamics. So, in a particular moist air analysis, we see that the partial pressure of water vapor is equal to the saturated pressure at the same temperature. So, what is the relative humidity? Now, relative humidity is defined as the ratio of vapor pressure to ratio, like if you have a mixture of air and water vapor. Okay, so we have a mixture of, whenever it's a mixture, it's ideal gas, both occupy the same volume. So whenever you have a mixture, the partial vapor pressure, okay, to the saturated vapor pressure, that how at the max how much it can hold at that temperature, the same temperature, is what is defined as relative humidity. Now it is given that the partial vapor pressure, water vapor pressure, is equal to the saturated vapor pressure at, so both are equal. So relative humidity is basically 100%. So it basically it comes from the definition of relative humidity. In fact, the relative humidity definition has to be, I mean, is the original definition of relative humidity is mass of vapor present by mass of vapor that can, the saturated mass, the mass of vapor that can be the maximum mass it can hold at that temperature. So m max. So now we apply the, assuming that the vapor behave like an ideal gas equation. So mass of vapor, so we apply PV is equal to mRT, okay, and volume is a given volume. So mass of vapor is basically depends on this equation. Mass of vapor is nothing but partial pressure of vapor into volume by R of vapor by T. Now maximum mass at that T would be when you have when it has the maximum saturated pressure it can hold. So that is max to R and T. So at the same temperature. So it's basically the ratio of masses boiled down to the ratio of pressures. So PV by Psat, because beyond Psat at that temperature it cannot hold, it will try to condense back. Okay, so that is the idea. So same thing. So most of the time, I mean, we don't use this definition, we use this definition, but both are equivalent as we have seen. Okay, so 100 percentage. Thank you.